All right, it's tip of the day. Today we have a not linear, some Taiwanese company maybe? Not sure, not linear. So raise your hand if you know who they are. It's an LN4898, not an LM, but an LN 4898. And it looks like it's an amplifier, although it's all in Chinese. It looks like it's going to be a diff amp coming into a section where we have kind of the push-pull type of thing to the speaker. The speaker goes on these two signals here. And it wasn't obvious because it's in Chinese, but we can read most of the data sheet. But I did take the PDF and drop it into Grok and said, here, please translate. So it made a very nice translation here. So it's a 1 watt output for 8 ohm loads, uses a bridge load structure to deliver high quality audio. There you go. It has a built-in shutdown pin. Turn it on and off to save power. It'll operate from 3.2 to 12 volts. No need for a couple of capacitors, but for network, it's a boost up capacitor. So if you look at something like a LM386, you notice that you have to have a bypass capacitor between the speaker and the device. Otherwise, it blows itself up. So raise your hand if you've ever done that. But yeah, it also needs to have a what do they call it? They're calling it a bootstrap here. There's a name for it. You have a capacitor and resistor to ground to make it more stable. And those two things are required on that part. And this one's just good to go. You don't need to do any of that stuff. Let's see here. Power dissipation, 800, 600 milliwatts, yada, yada, yada. Applications. When the power is greater than 7.5, excessive power output may trigger the chip's internal temperature protection. So that's nice. It's got that built in. VDD power, recommended to be no less than 1 microfarad. Bypass capacitors, 1 microfarad. Yada, yada. I have a 1 microfarad in mine. Avoid shorting the outputs might kill itself, so don't do that. Let's take a look at the Chinese data sheet. This is how it's used. So the speaker goes across these two pins, and then there's a feedback off of one of them in. So there's you can set the gain here with these two resistors. They have 100K, 220K. And then you AC couple it into the thing, so it's referenced about wherever its other thing is. Its other thing is set by this bypass going into the plus N, and it's buffered with this 1 microfarad capacitor. So the buffer is the bypass. This it takes the VCC and divides it by 2. All right, so this side of the op amp kind of thing is going to be 2.5 volts, and then the other side is going to be 5 volts if that's what you have it hooked to. You also can do it, make it diff if you want to. Let's see, what are some other numbers we'd get from the data sheet here? It's not audiophile quality. It's going to be 10% total harmonic plus noise. So, you know, it's a transistor radio type thing. There are some graphs that I really don't care about, but it's an SO8 package, which makes it super, super nice. So let's go over and take a look at one. All right, I have it hooked up here, just like the schematic and the data sheet there. I have everything, all the same values. And I'm going to bring in a signal, and we'll see if it makes a noise on the speaker. Let's see, let's go to the generator here. Let's see. Oh, I need to turn on the power. That's what I'm missing. Hook up 5 volts. Oh, there we go. And it works. Works just fine. Let's go ahead and turn on a sweep just for fun. Here we go. I'm sweeping between 1 kilohertz and 600 hertz, a linear sweep. Let's see, how about a logarithmic sweep? Same. I don't hear much difference between those two nearby things. Let's turn off the power here. Yeah, it does seem to do what it seems to do. Okay, that was tip of the day, an LN4898.